today's Git class. I'm really glad that you can join me today. I'm very sorry about the delays. We had some problems with the internet connectivity that we managed to sort out. It took a little while. So thank you so much for the patience and for joining me anyway. And joining in with yet another Git class. So since it's already 11:15, I guess we should dive straight into today's topic. And I think the first thing we should do is to go through some of the exercises that you did, because you've been given another problem set, which has been about branches and branching. And I've heard that some of you would like to go through exercise 8 and 9. Is that correct? Would you like to talk about those two exercises? Yes. So let's do that. Let me see if I can bring up the exercises on the screen. Let me see here. Studio mode. Let's choose the PDF reader. Okay. And now the exercises should be up on the screen for you. And exercise 8, that's the one about finding out which of the merges are fast forwardable. Which of the following merges are fast forwardable? And I wrote you two reminders here. One is that we say that if you merge branch X, if you've checked out branch X and you run git merge Y, we're then saying that you're merging branch Y into branch X. That's the terminology we're using. When you're merging branch Y into branch X, what you're doing is you check out branch X so that you've checked out the branch that you want to update. The one that you want to merge information and merge data into. And then you run git merge Y, and Y is merged into X. X is the branch that gets updated. Remember, whenever you're in Git, you have to check out the branch that you want to update. And when you're merging into branch X, X is the branch that's getting updated. And Y remains the same. Also, we've talked about fast forwardable merges, which is a special case of merging. And we've said that the case of when a merge is fast forwardable is when the commit when the head of the branch that you're merging into is part of the history of the branch that you're merging, right? So basically, the branch that you're updating is a previous commit. It's in the history. It's an ancestor of the branch you're merging. So there's a direct line between the two commits, chronologically speaking. So if we look at this with the first one, problem A. This is pretty much one of the simplest examples you could look at. I hope you can see the mouse pointer. But we started out with an initial commit, and that's where our master branch is. Then someone created a feature branch there as well. So in the beginning, we had master and feature on the same commit. And then someone checked out the feature branch and started committing to it. Let me bring up a diagram so we can look at what this actually looks like. Can you see the diagram? So we started out with a master branch. And let me increase the font size here so you can hopefully read it. And let me bring this down a bit. So initial commit, master, then what someone did was to check out a feature branch. And then they started committing to the feature branch. So they created a commit, which had this as an ancestor. Whoops. There we go. And that's where the feature branch is now. And the same thing happened again. And there we are. Now, the master branch, the head of the master branch, is now an ancestor of the head of the feature branch, right? Here's the feature branch, and we can go backwards through history. 1, 2, 3, and there's the head of the master branch. In other words, the head of the feature branch has just expanded on the work in the master branch. They've added incrementally to it. First by creating this commit and making an incremental change to the head of master, and then adding another incremental change. In this case, where basically the history between these two commits is completely linear, that's what's called a fast forwardable commit, fast forwardable merge. So when you're telling Git, I want to merge the code inside the master branch and the feature branch, basically what you're saying is that I just want to update master with whatever is in the feature branch right now. And that means that all Git does, since this is a fast forwardable commit, is to move the master branch over here. So first of all, this is a fast forwardable commit. And secondly, what that means is that when you merge feature into master, all that happens is that the master label, the branch, moves and master gets a new head, namely this commit. Did that make sense? So it seems like some of you understood that, and that seemed to make sense to you, but it's good to reiterate and review this material. And this is the simplest case. Let's go back to the PDF. The next one is identical, but here we're asking if you check out feature and you merge master, what's going to happen then? Is that fast forwardable? And in that case, no, because feature is newer than master. Master is an ancestor, and if you're trying to merge something older into something newer, you're basically saying that, I want this feature branch to contain the changes that are in an older commit, but those are already part of the history of the feature branch. So if you try and merge something older, as in an ancestor of a branch, into the branch, Git is just going to tell you, you already have this code. It's already part of your history. So there's nothing to do. So not only is this not a fast forwardable merge, it's just a no-op. It doesn't do anything. No-op being the computer science term for a null operation or a no operation. It just doesn't do anything at all. It's a no-op. Hopefully that makes sense to you. And you can see the difference here. In the first one, we tried to merge feature into master. In the other one, we tried to merge master into feature. Now let's have a look at C. What has happened here? Well, we had an initial commit. Someone created a feature branch. And there are two commits in that feature branch in addition to the initial commit. And then someone made a commit straight to master. Okay, and the question is, what happens if we merge feature into master? Is this a fast forwardable commit? Is this a fast forwardable merge? If we try and merge these two commits, is that a fast forwardable merge? And here we have the classic case of a merge that is not fast forwardable. Because in this case, there's a fork. You started at the initial commit and you went in one direction, and and someone started at the initial commit and went in another direction. And so if you look at the ancestors of the feature branch, that would be this commit right here, this commit right here, and this commit right here. It's those commits that are reachable by following the arrows from the head of the feature branch. Those do not include master. Those do not include the head of the master branch, because we would have to traverse an arrow in the opposite direction in order to get to. to get to the head of the master branch. So this is not a fast forwardable commit, fast forwardable merge. If you had to merge these two branches, you would have to do a full ordinary normal merge where you create a new merge commit, which will reconcile the differences that might have happened because, you know, someone took the code in one direction and someone took the code in a different direction, and you can't expect those changes that have been made to be fully compatible. They might be, in which case Git will automatically resolve everything for you. But usually someone over here will have touched a line of code that was touched by someone over here as well, in which case Git will ask you what to do about that line of code. So if in this case, I'm going to bring up the diagram again. Let's recreate the scenario. We had an initial commit here where the master branch resides, and someone created a feature branch. And then we don't know exactly who did it first, but at least someone created a commit on the master branch, meaning they created a commit which used the head of the master branch as its basis, changed it, checked it in, created a new commit, and moved the master branch over. Okay, and then someone else did something very similar on the feature branch. Let me see how I can move this to make it legible. They created this commit and they created yet another one, and let me see. There we go. The diagram was something like this, I think. Let me check the diagram. Yeah, it was something like this. What is important here is how the commits are connected. So we had a feature branch here with basically two commits in addition to the initial commit, and then we had the commit on the master branch. So the master branch has two commits on it, this one and this one. Okay, what happens if we merge feature into master? Well, Git will tell you that this is not a fast forwardable merge, and what it'll do is it'll tell you to do an ordinary merge, meaning that Git will tell you, you know, there might be some differences that Git can't automatically figure out for you. You have to do a manual reconciliation, and then Git will create this merge commit. With two parents, it'll have the head of the feature branch as its first parent and the head of the master branch as its second parent. And since we merged into master, the master branch is the branch that moves. So that's what the graph will look like after you're done merging. And this commit will contain the changes that were done on the feature branch and the changes that were done down here as well. You might have had to do some manual integration between the two code bases, but if you were lucky, or if these two commits were sufficiently different from each other that they didn't really touch the same parts and areas of the code, Git might have created this commit for you automatically. But no matter what, you'll get this merge commit with these two parents. So did that make sense? So first of all, that merge was not fast forwardable. And secondly, if you did do a merge, you'd get this merge commit. You still with me? Any questions so far? Or did that make sense? Just give me a thumbs up or a thumbs down, a yes or a no. Some indication that you're still there and listening to me. Because I'd be really sad if we had more technical difficulties today and the chat stopped working or the connection dropped out or something. Still there, guys? Anyone? Just say something in the chat. Thumbs up. Awesome. Thank you. Thank you so much. Then let's move on. Problem D. Let me see here. Is that different from C? Yes, it's different in that there is a loose dangling commit there. As far as we can see from the diagram, it's not on a given branch. That doesn't really matter to this problem because we're concerned with the feature and the master branches. And we only need to know where those are. So let's go back to the diagram, this one. And what was the situation like? Feature branch here, right? Master branch down here. And we have this dangling commit. We're not sure if there's a branch pointing to it or not. It doesn't matter. The question is, if we merge feature into master, is this a fast forwardable merge? And again, I mean, you don't really have to be concerned about this commit. It's not part of the problem. What we have to look at are where the heads of the branches are, as well as what the history or what the histories are like on the two branches that we're merging. Again, what we're looking at is whether or not the head of the master branch, which is this commit, is part of the history of the feature branch. And if we look at the history of the feature branch, it consists of this commit and this commit. I'm just following the arrows here. And this commit. Wouldn't you know, that's the head of the master branch. So in this case, the merge is fast forwardable. And if we merge feature into master, what will happen is master moves up here. And that's it. Yes, that merge is fast forwardable. And that's what a merge will look like. Back to the exercises. Exercise E. Okay, what has happened here? It seems like we have some sort of merge has occurred already, so feature has a bit more of a complex history. And we're asking what will happen if we try and merge feature into master in this case. Well, let's bring up the diagram again. The diagram tool, that is. So, the situation looked approximately like this. We had two commits on this spout here, which went to this merge commit over here. Well, in order not to confuse people, I'll just draw the diagram exactly as it is on the paper, on the exercise sheet. There, and I was never very good at arts and crafts. But this is a tool for dummies, so I should be able to do this. There we go, here and so. And the feature branch is here, and the master branch is here. Okay, what could have happened here? Well, it seems like at some point the feature branch was here, then someone merged master into feature. Is that what might have happened? No. Someone merged feature into master, moved master back here, and moved feature here. Okay, I mean, this is not a situation that you might commonly see, but what could have happened is that feature was here, someone merged feature into master, non-fast forward, forced the creation of this merge commit, moved the master branch down here, and moved the feature branch over here using git reset. However, whatever the situation was like that created this graph, that's not important. I didn't create this graph because it made sense in terms of what situation created it. It's just a valid commit graph. Someone somewhere could have created a graph like this. And the question is, what would happen in this case if you tried and merge feature into master? And the question again is whether or not the head of master, which is this commit, is in the history of the feature branch. And which commits are in the history of the feature branch? Well, we just have to follow arrows. We start at the head, and we can go in this direction. So this commit is in the history, and this commit is in the history, and of course, this commit is in the history. And if we follow the other arrow, we're back here again. So this commit is in the history. The head of the master branch is in the history of the feature branch. If we merge, this is a fast forwardable merge. And Git will do this. Okay? And that's basically what there is to know about fast forwardable commits. Fast forwardable merges. Not sure why I keep making that mistake. Fast forwardable merges. Okay. Did that make sense so far? I think that'll be... we went through whether or not the merges were fast forwardable, and we also looked at what the graph would look like when you were done. So I think we did both exercise 8 and 9 there. Yeah. Okay. So, any questions? I think we spent about 15 minutes doing that, so that should be okay. But, right, just any questions? Does anyone still feel that the concept of a fast forwardable merge, does anyone think that that's a difficult concept to grasp, or does it seem like a strange concept? Does it seem unintuitive? Does it make sense that the notion of merging in the case when the head of one branch is in the history of the other? Does it make sense that merging works the way it does? Remember, merging is all about integrating work. The point is that if you can go from this commit to this commit in a straight line, so to speak, then this commit up here, it has sort of incrementally added to this commit. And therefore, if you want to integrate the work in this commit and this commit, you're basically saying, you know, I started out here. We've already made some decisions based on what is in this commit. And therefore, if we now want to integrate this work into where this commit is, the branch here, you just move the branch over. You just add all the changes that have been made since. We just move that label over. Hopefully it makes sense. And if not, hopefully it will with some more experience. Well, it definitely will. And in the other case where you've branched off into different directions, then hopefully it makes sense that someone, either Git or you or both, will have to make some decisions about how to integrate the work, because you started out at this common point in the graph in history, and you went in two different directions. Someone did something here, someone did something here. At some point, some integration will have to happen. You have to make some decisions about what the end result of bringing that work together will look like. Now let's move on. Yesterday we talked about rewriting history, and that basically means, you know, changing the commit graph. But, right, we have a question here. When you merge master into another branch, like feature for instance, you're left without the master branch and feature becomes the new master. No, no, that's not the case. The branches still exist. All that is done is that the head of the branch, as in where that branch points, that's changed. Let me bring up the diagram again. And let me tell you how this works in real life. Basically, you start out with your initial commit. This is the first code that you check into your Git repository. Usually it's just a README file, but maybe you've checked in some initial code as well. And you start out with that initial commit as well as the master branch. Now, what you're doing is that whenever you work on a software project, you want to plan ahead. You want to say, you know, in order to implement this project, in order to complete this project and create the product I want, we have to create different features. We have to create different parts of this project that we should work on in parallel and keep separate from each other. So say you make a chat application. Someone will maybe make the web view, and you have a feature branch called feature web view. And someone might have to create the user login system, etc., etc. So let's say that you're two people and you're working together, and one of you is creating the web view and one of you is creating the login. What you do is that both of you will check out the repository and both of you will get this commit. And then the guy who's creating the web view will create this feature branch for the web view. And the one among you who's responsible for the login will do the same thing, but will create a branch for that. And the guy working on the web part of this will then start committing to the web branch. Whoops. Control C, that's what I was looking for. So you'll get a few commits, at least one, and probably 2 and 3 and 4, and it could be a lot. And anyway, this is where you're going to be. And the other guy is going to do the same thing with the login functionality. I mean, setting up the database structure and creating models and doing all that stuff. Okay, the branches remain. I mean, at this point, the master branch is still there. It's called master. It exists in the repository. It's just that it's still at the initial commit. So if someone checks out the master branch, this initial commit is what they're going to get. And it will contain just the README file and maybe some initial code, but that's it. Because all the development is happening in these other branches. Everything that's happening that concerns user login, the login code, the authentication code, whatever, the code that allows the app to contact the database and query about users, that is happening along this line. And anything that happens with regards to what the web app looks like, the HTML code, etc., that is happening here. And in these commits, you'll get different files committed. These branches still exist. They move along with the development. Now, at some point, the login feature will be done. You've implemented the last line of code you need in order to have that feature. The feature is ready. At that point, you merge the login branch into the master branch. And as I said, when you do a merge, in this case, that will be a fast forwardable merge. So what would happen if you just did a normal merge? The master branch moves and will now be here. And usually when you're done with the feature branch, you just delete it, so it's gone. And the master branch now contains all the work in the login branch. The master branch still exists, but now it's moved. It's moved to this commit. The master branch now contains the login code. Now, what happens when we're done with the web view? Well, in this case, we'll have to merge this code into the master branch. And in this case, it's not a fast forwardable merge. So Git will say, now we've branched off. Someone injected some login code and we've sort of branched off in different directions. So you're merging, you get the merge commit, and let's see here. This commit here now will contain both the login code and the web view code. Master branch moves along with it. Master branch still exists, but it now points to this commit. So whoever checks out the master branch after the merge was done will now get this commit, which contains both the web view code and the login code. And once you're done with a feature branch, of course, you usually delete it. So there you go, and that's what the graph will look like. Did that make any sense to you? Or did that answer the question? So we're never left without a master branch. And branches don't change their role. Remember, a branch is just a label. So the master branch is just a label that you move along with the commit, and it never changes name. A feature branch never becomes the master branch, but it designates a commit, and whenever you choose to integrate work between branches, the branch that you're updating, the branch that you're moving, that you're merging into, will move along with the code that is integrated into it. So this is what it looks like in real life. At least this is what will happen if you just do completely normal merging. But today I wanted to show you a new workflow, or we were talking about rewriting history. And I wanted to talk about alternative ways of integrating code. And that is something that goes by the name of rebasing. So if we go back to our slides this time, and go back to our section about rewriting history, we talked about interactive rebasing. Remember the modifier interactive. Interactive rebasing is used to change commits in your commit history that you're not happy about. Changing a commit message, changing the author, maybe even changing files, or changing things that were staged and put onto the index that shouldn't have been there. And we looked at git rebase -I yesterday and how you can refer to commits in order to get a list of commits that you can modify. And we did that together yesterday. Now we're going to talk about rebasing without the interactive modifier, just rebasing. And this is a very important tool that you need to know about because it's very commonly used, and it's very commonly used in conjunction with merging branches and merging feature branches. It is all about rewriting history. And I will show you what that entails. Now, the definition that I wrote on the slide is that rebasing is the action of moving a sequence of commits to a new base commit. What could that possibly mean? Well, if we look at the graph, and again, remember, Git is a graph manipulation tool. Imagine that you had a feature branch. Look at the grayed out part here. You started at an initial commit on the left-hand side, and you had a feature branch there with 2 more commits, and those are now shown in gray. Then someone committed to the master branch, some changes happened to the master branch, and you got 2 more commits on the master branch. Well, sometimes in order to integrate the work that is on the master branch without merging the feature branch, say some changes happen to the master branch, and those are important to what you're doing on the feature branch, you need to make sure that you get those changes on your branch, on the feature branch, But you're not done. You're not ready to merge yet. You're not ready to integrate your feature branch into the main line of code. You just need to make sure that you actually have everything that is on a master branch because it concerns you. In that case, what you'd like to do is to move the feature branch so that your commits are actually emanating from the latest commit on the master branch. They will contain all the changes that have happened on the master branch. And this is why I talk to you about Git commits as being interpretable as change sets. Let me try and bring up the diagram again. And let's recreate the situation on the slide. So we started out with an initial commit, and oops, I deleted the branch labels. We need a branch label. There. That's where the master branch is at. Someone created a feature branch. 1, 2, and this is the situation. Someone committed those commits to the feature branch. And a couple of commits happened straight to the master branch. Whoops. And there. Okay. Now, let's say something happened here. Maybe you changed your database framework and your feature branch is using the database framework. Or someone made some change that you just have to make sure that you have on your branch. Well, remember how we said that, you can interpret the commit as being the changes that happened between the commit and the previous commit. Basically, you can use Git to say, this commit is represented by what changes you had to make to this commit in order to get to this commit. You have to add a line between line 11 and 12, which contains content so-and-so. You have to delete line 5. You have to append to line 7, etc. And that's how we got from this commit to this commit. Right, but what you can do is you can sort of replay those changes on this commit. So you take the changes that happened between this commit and this commit, and let's label these commits so that they have some names. You replay those changes and you create another commit that mirrors the old one. So let's call it X prime or something. It mirrors the old commit. So, oh, sorry, of course that arrow should go the other way around. You can take this commit, you can say to Git, I want to take the changes that happened between this commit, and I want to replay them from a different commit. And thereby creating a new commit. And you do the same to this commit. You're saying, some change happened between X and Y. I want to replay that change on the new X. Boom. And let's call that Y prime. And after you've done that, you'll move the feature branch over here. Now, what have we done? Well, we've basically recreated the feature branch, but at a different point in the graph. We moved the entire feature branch. In reality, we created some new mirrored commits, but you can think of it as just moving the feature branch. Now, of course, just like with merging, we could be in a situation where some of the changes that happen between this commit and this commit cannot be replayed here. For example, a line that you modified here could be gone in this commit. And other similar areas could happen as well, or similar inconsistencies. And in that case, Git is going to tell you, just like when you're merging, during the rebase process, we have some rebase conflicts and you have to help me solve them. And it'll be the exact same kind of workflow as when you're merging two branches in a full merge. You're going to be told, we have a rebase conflict, and you have to help me figure that out. But after you've sorted that conflict out, the result is that you've moved the entire feature branch. And in a sense, you don't need these commits anymore. So there's no branch here, and if you don't do anything to these commits, in a little while, Git will just garbage collect them and delete them for you. Your Git graph then looks like that. So, does that make sense? Rebasing as a tool. Do you understand the concept? Does it make sense that this this feature of Git exists? It's very, very commonly used. And in certain workflows, people want to rebase everything. And let me show you why. Let me bring up the diagram again. Here we go. Okay, so let's go back to our example with the chat application that had a feature branch for the login, and it had a feature branch for the chat feature. No, web view, sorry. So again, and how many commits do we need? 1, 2, 3, 4, something like this. Here and here and here. You still with me, guys? By the way, give me a thumbs up if you are. Give me a thumbs down if you're not. Just let me make sure that I just want to know that you're still there and that you're still with me while I'm recreating this graph. Okay, this is what the situation looked like. Right. Well, now when it comes to merging feature branches, I've told you about forcing non-fast forward commits. I've told you that, you know, this merge is fast forwardable. If we merge master into, no, sorry, if we merge web into master now, this is a fast forwardable merge. We could, if we just do an ordinary merge, this is going to happen. Now, however, some people think that, you know, whenever we do this, our history becomes a bit, not cluttered, but, you know, this commit here on the master branch, it contains some unfinished code, right? Because what happened is that on the way to implementing the web feature, we had this commit here, which contains some unfinished code. The code on the web feature got finished here with this commit. And if we just move the master branch over here, what ends up happening is that you basically get this unfinished commit as part of master's history. And if you go through the history, if for some reason at some point you notice that, oh wow, there's a bug in our code, we have to backtrack, go back through our history and publish an older version of our code. Then you need to know which of these commits are safe to ship to the customers. This one might be because it integrated a full feature. This one contains partial code. If you say, oh, we'll just backtrack, we'll put the master branch here, and we'll now just ship this code instead. We'll publish this code online. No, that's a problem. It's unfinished code. You shouldn't do that. But your commit history doesn't tell you which commits are safe to publish, which ought to be this one, which was the initial commit on the master branch, and this one, because it contains a fully implemented feature. Well, what do we do? Well, there's two different approaches. One is using interactive rebase before you merge this feature branch. And what you're doing is before you're merging the feature branch, you're running interactive rebase on the feature branch. You select these two commits and you squash this commit. Squash means that you basically just remove it from the history so that this code is all that's left. And you have just one single commit on your feature branch because the feature's done. And then you merge. That's one way of doing things. Another way of doing things is if you want to retain the information in this commit, maybe at some point you want to go back and you want to check, what did this developer do? How did they implement this feature? What code did they add first? Then what did they add? Etc, etc. Then maybe you want to keep this commit as part of your history. In that case, you can force a non-fast forward merge. In that case, what will happen is that Git will say, you know, I can see that this is a fast forwardable merge, but I'm still going to create a merge commit. So even though we're merging something that could be fast forwarded, we're going to do it this way. We're creating this merge commit. Let's see if we can make the arrows pretty. No? Here. Okay. All right. Never mind. We create this merge commit. And this merge commit is going to be identical to this one. But now at least as part of the history, as part of the commit graph, you can see that the commits that are on the master branch will all be merge commits. And the commits that are on these handles, those will be the unfinished pieces of the code. So you can see directly from the graph, when you look at the graph, that yeah, okay, we're on the master branch. This merge commit here, that's a safe commit. And everything that's not on a merge commit, that has to be regarded as an unsafe commit that we can't just push out into production. Now, where does rebasing come into this? Well, if you always make sure to merge your branches non-fast forward, as in even though your branch can be fast forward merged, and you just make sure to tell Git, I don't want that. I always want to create the merge commit when I merge. If you don't remember how that is done, there's a previous slide on it, and we'll look at it in class as well. We'll go through this process together in the terminal. The point here is that what you can do here is that the next guy who's now integrating his work, what does he want to do? Well, what he can do is to just move his branch over. By rebasing his branch on the new master commit. In that case, what you're basically saying is that once you want to integrate new work, make sure that you rebase your branch on the latest work that is already on the master branch. And what will happen before this guy actually integrates his code is he'll rebase his entire branch. Move it over here. Whoop. Okay. Wow. Come on. All right. And now he can merge his branch non-fast forward. And then the graph looks like this. So this is a very common way of doing things in Git, and it's called a rebase-based workflow. It's the workflow where whenever you have finished your feature, you make sure to rebase your feature branch on the latest master commit. In doing so, you're integrating everyone else's work so that your branch is then ready to be fully integrated. Basically, you're taking everyone else's changes into account before your feature is merged. And it creates a very clean looking graph. Whoop. Oh, I don't like how it moves the arrows. Oh, there we go. It creates a very nice and clean looking commit history. And it makes it very easy for you to look at previous commits and say, you know, I know exactly which commits contain full features, which contain code that is in a state that is ready to be either shipped or tested, at least in a state where it's ready. And also it's very easy to see which commits contain partial work, half written classes and half written code. That is just part of finishing a feature. So that's Rebase based workflows. And you have to decide for your own project whether you want to just merge normally, as we've already talked about. Whenever you're done with a branch, you just merge and create a merge commit, or you fast forward whenever that's possible, or you make sure to always rebase your feature branch on the latest commit. That is something that you have to decide on. There's no right or wrong answer. It's mostly a matter of taste. Now, I know it might be a bit abstract, but we're in our next class, we're going to go through an actual example of writing a simple application with two separate features, and we're going to integrate those, and we're going to look at rebasing and see how that works in real life. So, I guess that's enough for today. Any questions about the material we've covered so far? Did the concept of rebasing seem like it could make sense to you? Does it make sense? Does its purpose make sense? Or did it not? At any rate, we're going to go through this again. You need to practice more. Sure, absolutely. We're going to look at this and what it looks like in real life in our next class, which is going to be next Monday. So don't worry, it's going to make sense. Thank you very much for joining in today. I'm sorry that we didn't do much practical work today. It was mostly slides and discussion and theoretical stuff. But we'll get back to practical Git next class. So thank you very much. I'll try and sort my microphone and internet out for our next class. Hopefully don't run into these issues again. But yeah, until next time, I'll see you on Monday. Bye-bye.